Hello guys, in this video I'm going to explain that how to find R equivalent when resistors are connected in series and resistors are connected in parallel. Now let us assume that I have given a circuit. In that circuit we have a source, that means that may be voltage source or current source, and also we have n number of how many n number of resistors are connected in series and parallel. So our ultimate goal is we need to find R equivalent resistance for that circuit. Now if you want to find R equivalent, first you need to understand that how to identify that the given elements are connected in series and parallel. So once if you can identify, so we have some formulas. Okay, by using that formulas you can find the R equivalent. So in my previous video I have explained about voltage, current and resistance. So here I am going to draw a simple circuit which is having a voltage source and one resistor, and these are the connecting wires. So you know the role of voltage, right? Whenever I connected a voltage, it will push the flow of electrons. So the current is flowing in this circuit through the connecting wire. Then what is the use of resistance? Resistance will resist the flow of electrons. So as per Ohm's law, V equal to IR. So if you want to find the voltage drop across resistor, you can use it. V equal to IR. So what is the current flowing at this resistor and the resistance value. So if you want to find current, I equal to V by R. So here what you need to understand that the current is what? Directly proportional or inversely proportional. So the current is inversely proportional to what? Resistance, yes or no? So if the resistance value is higher, then what happened? Current in that circuit is low. If the resistance value is less, then the current in that circuit is very high. Now here, now you just assume that I have given a two resistors R1 and R2. Okay, this is R1 and R2. Now for just some time you understand that these two resistors R1, R2 are connected in series. Now how to find R equivalent? So you can find R equivalent simply you have to add these two resistors R1 plus R2. Clear? Now that would be what? The R equivalent. For example, here this R1 is 2 ohm and R2 is 2 ohm. Then what would be the R equivalent? 2 plus 2 equal to 4 ohm. This 4 ohm is what? R equivalent of these two resistors. Clear? Now here I am taking the same resistors in parallel. So here this R1 and R2 are connected in parallel. Okay. Now how to identify R equivalent? So we have one formula. So you can write 1 by R equivalent equal to. So this R1 and R2 are connected what? In parallel. Therefore 1 by R1 plus you need to write 1 by R2. Now in order to find R equivalent, first do the LCM here. What is the LCM? R1 and R2. So if you do the LCM, you will get what? R2 plus R1. Therefore, what we need? We don't want 1 by R equivalent. We want just R equivalent. Yes or no? So R equivalent means this denominator will go to numerator and numerator will come to denominator. R1, R2 by R1 plus R2. So this is the formula when elements are connected in parallel. So R1 into R2 by R1 plus R2. So if elements are connected in series, you simply add R1 and R2. Now let us consider that this is what 2 ohm and R2 is 2 ohm. Then how to find R equivalent? Simply you need to write R2 into 2 by 2 plus 2. So this is what 4 by 4. So therefore this is what 1 ohm. Now this circuit you can write it what? You can represent like this. This is what? R equivalent with the value of 1 ohm. Now this one A and the circuit B both are same, no difference at all. Okay, no difference at all. Now here this circuit A and this circuit B or the connection A and B both are same, no difference at all. Okay, clear. Now see here, when elements are connected in series, what happened? The resistance is what? Increasing, right? So if the more the resistance, what happened? Less the current in that circuit. Now if elements are connected in parallel, what happened? Here before finding R equivalent, 2 ohm at R1, 2 ohm at R2. Now R equivalent is what? 1 ohm. That means the resistance is what? Decreasing. So if the resistance is decreasing, what? Current is very high at that particular circuit. Now instead of 2 ohm and 2 ohm, let us consider R1 equal to 4 and R2 equal to 4. In that case, what happened as per this formula? 4 into 4 by 4 plus 4. This is what? 16 by, and this is what? 8. Therefore 8 ones and 8 twos. What happened? This is 2 ohm. Now when the resistor R1, R2, 2 ohm each, what is the off in that? 1. So we are getting 1. So when the resistor R1 and R2, 4 ohm each, what is the off in that? 2 ohm. So the resistance is going to be decreased when the elements are connected in parallel. Now you need to understand that how to identify these elements are connected in series or parallel. So to explain that one, so here see, I'm going to consider a voltage source. Okay, so here we have what? Two circuits, two resistors are connected. Now here, as I am using a voltage source, let us consider this is R1, R2 and R3. So here, as I am using this voltage source, what happened? Some current is flowing, right? Yes. So let us assume that is what? 5 ampere current. 5 ampere current is flowing, coming from where? Coming from source. Now see, this 5 ampere current is coming here and here. Now you just imagine that water pipe, okay, water pipe connection. So whenever you have a connection, suppose imagine just a water pipe connection. Now water is what? Coming like this, like this, like this. Whenever you have a joint, some water will go here and some water will come here. Therefore now this part 1 and part 2 connected what? Parallel. Now once again the same water is coming here. Suppose let us assume this is what? Your water pipe. Now after coming here, what happened? Some water will come here and some water will go there. Suppose this is what? 3 and this is 4. Now you can say 3, 4 are connected parallel and 1, 2 are connected parallel. So how you are classifying this? Whenever the total water is going to get divided into 2 or many parts, those parts are connected what? Parallel. Now see here, 5 ampere current is coming here. So do you have any deviation here? No, because this is what? Series connection, like water pipe. So same 5 ampere current is coming. So if I ask you what is the current here, you will say 5 ampere. Now see what happened after coming here. It has two direction, like this and this one. Now this 5 ampere current is going to divide into two parts as per resistance value. Let us assume that 1 ampere current is coming towards R2. So if 1 ampere is coming, so what is the current flowing at R3? So the total current 5 minus 1 ampere equal to what? 4 ampere current. Now see, 4 ampere current is flowing through the R3 and it is not going to be divided anywhere. Now what is the current here? 4 ampere. Now this 1 ampere current is coming here, right? So this 1 ampere and 4 ampere will get combined, right? So that I can add 1 ampere plus 4 ampere here. So what is the current here? 5 ampere. Now total how much current is flowing in the to the circuit, to the source? 5 ampere. Now how much current is going from the source? 5 ampere. And how much current is coming to the source? 5 ampere. So if this is both, if this both are same, then your assumption is correct. Okay, until here fine. Now I need to understand that, so this R1, R2, R3 are connected series or parallel. So see here, you always go from left to right in order to find R equivalent. Now see here, so what is the current? The current is what? Dividing, right? The total current is dividing to the R2 and R3. Therefore, the current is going to divide into two parts. Therefore, this R2, R3 is what? Connected in parallel. So you know, right, what is the formula? So you can write R equivalent equal to R2 into R3 by R2 plus R3. Let us consider this R2 equal to 2 ohm and this R3 is also 2 ohm. What happened? So 2 into 2 by 2 plus 2. Okay, this is what? 4 by 4. So you will get what? 1 ohm. So instead of R2 and R3, can I write 1 ohm? That is what? R equivalent. So in the circuit, we need to modify. See, did I change anything at R1? No. So instead of this R2, R3, I'm going to write how much? I'm going to use one resistor with the value of 1 ohm. Yes, now this is what voltage source. Now see, these two elements are connected in series or parallel. Of course, these two are connected in series. Let us assume that 5 ampere current is flowing, going from this source. Now, will it divide anywhere else? No. Same, what current is coming to the source? 5 ampere. Therefore, the current is not dividing anywhere. Therefore, this R1, and so let us consider this is 2 ohm. Okay, this 2 ohm resistor and 1 ohm resistor is connected what? In series. So if these two are connected in series, what you need to do? 2 plus 1. This is what? 3 ohm. So this is how you need to identify the elements are connected in series or parallel. If elements are connected in series, you need to add these two. If elements are connected in parallel, so you have formula R1 R2 by R1 plus R2. Okay. So if you want to, if you get confused that whether these elements are connected in series or parallel, you just imagine a current, a water flow in the pipe. Okay. So whenever the water is going to divide, then these two parts are what? Connected in parallel. Or you can consider like that, you can assume some current is flowing from the source. Okay, so if the same current is coming, then your assumption is correct. So here what? So this R2 and R3 is connected in what? Parallel, and the resultant R1 and 1 ohm is connected what? In series. So that